under operation and maintenance center. And as I told you, same thing will be happening. Centralized operation for various units in the system, and functions need to maintain the subsystems. Like in order to work, it will be providing some keys and some algorithms from which MSc will choose which algorithms to take off. Like for authenticating the user and for some authentication process, some keys will be exchanged. These keys will be exchanged from HSS. And so same thing, like whether it is like fault reporting and alarm handling, like whether he is valid or not, and configurations related to that subscriber, and performance. These things will be, and database will, like HSS is nothing but some database, right, which will hold the user profile. So these things will be taken care by operation and maintenance center. Coming to security, so security in GSM. How do you think security is achieved in GSM when compared with 1G? I told you yesterday, right? Maybe day before yesterday. So just now I told you, like authentication. Authentication in the sense some keys and algorithms will be exchanged based on which encryption will be done and integrity will be achieved. So what is the difference between integrity and encryption? We'll be having ciphering algorithms and integrity algorithms. We are having three as of now: AES, JUC, and Snow3G. These three algorithms will be used for both ciphering. For ciphering, we have in the same algorithms we have for ciphering and also for integrity. Okay, these three algorithms will be used as of now for ciphering and integrity. In this way, we'll be achieving security in the GSM. On air interface uses encryption and TIMC instead of IMC. Because see, you are using IMC, but there are chances like some other person may know you are IMC and he may peep into that. So that because of that purpose, what the network will do is, once the connection is established, first initially you will be requesting for the connection, and MSc has provided you some connection and whatever you want, some access to the resources, those things are provided. Then what it will do is, it will, from then onwards, once you are established with some connection, then onwards you will be given some other identifier rather than IMC. That identifier is nothing but IMC. And whenever, even in roaming conditions, whenever you go to some other state or some other kind, maybe some international tool, that time also you are given with TBC. Yesterday I told you, whenever you go to some other place, in visitor location register, VLR will be giving you TMSI, nothing but temporary mobile subscriber identity instead of IMC. And even when you are connected, by sharing this will be shared only between the network, so no other persons will be knowing this TMSI. In this way, we will be having some security in GSM. And moreover, you uses algorithms for that, encryption and decryption algorithm, and they'll be sharing keys only with the user and the network. No other user can have this keys. Even though people receive, they can't write. Right? So in this way, security is achieved in GSM, and SIM is provided with 4 to 8 bit pin to validate the ownership of the SIM. I told you, we'll be having like a password for the SIM, and if it is blocked by some chance, then you will be having PUK service. With the help of that, if you call to that operator, he will be providing you what the PUK is registered with, and with the help of that, you can be able to unlock your phone. See, these are the three algorithms used for authentication. Like algorithms varies from 1G to 2G. Like more enhancements in the algorithms even came into the picture. In 4G, we are using AES, Snow3G, and JUC. Here, the algorithms which used are A3 algorithm for authentication, and A5 algorithm for encryption, and A8 algorithm for key generation. These are the three algorithms which are used for that authentication process and encryption process. Okay. So in this way, security is achieved in GSM, and characteristics will, like you know, right? We'll be having voice services, multimedia services, SMS, and same thing. It uses this bands, 900 and 1800 megahertz frequency band will be used for GSM. That is the reason you will be seeing in your specification GSM 900 megahertz, GSM 1800 megahertz. These bandwidths are used by GSM in order to provide you the services. And authentication from fraud control. Like full international roaming capability, even though you go to some other place, it will be working, and it will come under roam. Uh, Low speed data services. When compared with 1G, it has high speed data services. No, in 1G we are not at all having data services, right? It is data packets. That is only 1G is only having analog modulation. In the sense, analog signals are only it is capable of transmitting only the analog signals. But in 2G, it is not the case. Data services are started with 2G. And since it is the starting phase, the data rates are very low. When in 3G and 4G, in 4G we are almost having in Gbps, almost 50 Gbps, 100 Gbps. It depends on downlink and uplink. I told what is downlink and uplink, right? What do you mean by downlink? What is downlink and what is uplink? Please respond. What is downlink and what is uplink? I'm just asking you small questions. Okay, fine. Downlink in the sense whenever traffic is flowing into your phone, into your mobile phone from the network. Maybe it is from base station to your mobile terminal. That it is downlink, right? It is which is coming from base station to user terminal is called as downlink. Whereas you are uploading some video into the some net, you're giving something, you're uploading some data, you're uploading some documents. These kind of things will come under uplink. Generally, you'll be downloading movies, these kind of stuff, right? So your downlink bandwidth will be more when compared to the uplink bandwidth because it is normal, it is general, like users will be downloading rather than uploading, right? So because of that, uplink is provided with less bandwidth and less bit rates. So downlink is provided with good bit rate. And in downlink, we'll be having, you know, what is multiple access techniques? What are multiple access techniques, right? In downlink, what will be in LTE, will be using OFDMA. And in uplink, SCFDMA. So the bandwidth and the number of users served will also depend on this multiple access techniques and multiplexing techniques. So based on that only difference will come. Like in downlink, why it is a high bit rate, and in uplink, why the bit rate is low, because of multi. Okay. Advantages of GSM over. I think this you can explain a bit better, because as of now you do know what is 1G and what is 2G and how it is. More advantages when compared with reduced RF transmission power and longer battery life. See, here you will be having more battery life. There, like from generation to generation, there are many techniques coming into the picture. So in 4G, we are having one technique like DRX. DRX is nothing but discontinuous transmission and reception. So whenever you want, you can, like, the mobile will be activated whenever it is receiving something, and whenever it is sending something, then only it will be active. And in the remaining state, it will be in idle mode. But like it can't check for everything, so it will be like going to sleep and coming up, going to sleep, coming up. These kind of things will be performed in 4G. So similarly here, your battery life is increased and the RF transmission power is reduced. International roaming capability, you know this, and better security against fraud, because in 1G you don't have any security mechanisms. Here you are having the algorithms. And the user is also authenticated. Once he is authenticated, then only he is provided with services. Otherwise, no services are provided to him, and he will be kept in blacklist also. encryption capability for information security and privacy. So these are the advantages. GSM applications are these applications. There are many applications in mobile phones you are using for voice, like mobile telephony and telemetry, in vehicles and in petrol bunks and toll collection. For these all services will be using GSM. These are some of the applications which uses GSM. And the future of GSM will be like as I told you, in GSM comes under second G and the data rate is 9.6 kbps, right? So this uses circuit switched basically, and from 2.5G in 2. Yeah, here it is mentioned, right? 2.5G future of GSM, high speed circuit switched data. Here it is circuit switched, here also it is circuit switched, and the data rate is increased, right, into 8 kbps. Here it is 9.6 kbps. When coming to HSC SD, it is 9.6 into 8 times. 8 times it is increased. The speed has been enhanced here, and this will GPRS. Even GPRS will also come under 2.5G. And in GPRS, what they have done is they used packet sort of circuit switching. So what happens? There is like no bandwidth is reserved for two persons. Like it can take, the packets can take any parts, and after receiving there, the receiver will do some operations and it will rearrange the packets and they will be using. So because of this, the data rate is highly increased because of packet switching data network. The data rate has increased from 14.4 to 115.2 kbps. See, almost 9 into 10, maybe 10 times, right? And then Edge came into the picture. Edge is nothing but enhanced data rate for GSM evolution. Like from one phase to another phase, there are many changes happening. That changes will be in maybe type of modulation used, type of multiplexing used, access techniques. Based on because of these techniques and error control, these mechanisms, what they'll be doing, if the channel quality is good, they'll be going with some higher modulation and some higher multiplexing technique. So because of that, data rate will be increased, right? So whenever you have only TDMA, data rate may be slow. But whenever you have combined of you have TDMA together with FDMA, the data rate will be high, right? When you go to CDMA, it will be more high. When you go to OFDMA is nothing but orthogonal frequency division multiplexing. Frequency multiplexing, I think you know. Frequency division multiplexing in the sense each user is allotted with a pair of channels, one downlink and one for uplink. So in OFDMA, what happens is this: you are having some bandwidth, same bandwidth which is provided in the FDM. That bandwidth, what we'll be doing is we will be dividing that band into small carriers. You are having some bandwidth, 1.4 megahertz. So what you will be doing, you will be dividing the band into some subcarriers. So each subcarrier will be served with one user, and we'll have to make sure that the subcarriers present adjacent should be orthogonal to each other. Then only there will be interference kind of thing, right? If suppose the adjacent things are of same frequency and then if their phases are same, what will happen? Interference will happen and you can't receive none of the signal transmitted in channel A and channel B. So for that purpose, we'll be having orthogonality between the two adjacent subcarriers. So that is OFDMA. So the techniques, I mean, by doing some enhancements in the techniques, we are achieving high data rates. So Edge has achieved almost 547 to 2 kbps. And third generation, in third generation we'll be having CDMA, which will provide the data rates of 0.3482 to 2 Mbps, and in 4G also in LTE we'll be having 100 Mbps in downlink and maybe some 4 to 5 or almost 50 Mbps in uplink. Then GSM protocols. Okay. Yeah, it is visible, right? Yeah. What is handover first of all? Yeah, I think you know all this stuff yesterday only I explained. No, not repeating. I'll just cover this handover concept in maybe 10 minutes and I'll go off with the protocol. And there is no need to change to another base station, and there is a need to change to another base station. It is called as handover. See, here the mobile first he started here and he is connected to base station 1. When he is moving, he is getting signals from both base station 1 and base station 2. So what like here when he is moving near to base station 2, he is moving towards base station 2, then the signal strength of BS1 will be decreased and the signal strength of BS2 will be increased, right? I told you we will be having two factors, actually four, many factors will be influencing this handover, out of which I can say like RSRP, received signal strength power. Power will be more from BS2 when he is going near to BS2, and quality. What is the quality of the signal? Each user is provided with one quality of service whenever he begins whenever he requests some kind of service, it may be data or something. So suppose it is voice. So under QoS, quality of service also will be having different classes. So we are having all four classes, and after, for that, for each class what we'll be doing is like based on the like this class will be allocated for data services, this will be allocated for users like voice services, and this will be allocated for some other multimedia services, this kind of thing. It will be divided based on that, and also the based on the payment, like based on the charging rules, there will be charging and enforcement, right? That will be taken care in OMC. So based on that, based on what subscriber is preferring and based on what he subscribed to, based on that services he will be provided with based on that services. And one more thing which influences this handover is congestion. Suppose you are going to base station 2, but there is no like this is completely occupied with all the users and it has no channel so that it can serve the mobile station. So in that purpose, it can't attend the new one. It can't terminate the existing user and it can't attend the this, right? So there one scenario which will come into the picture is it will share with whatever mobiles are present in base station 2 that may be common to some other base station 3, right? So what it will do is if that base station 3 is not under congestion, if it is capable of handling this phone, handling the mobile subscriber under base station 2, what it will do is it will hand over to the person like who is in between of base station 2 and base station 3. It will hand over its own customer to base station 3, its own mobile subscriber to base station 3, so that it will be now it can handle like now it can handle one more mobile, right? Now it can serve one more mobile. So what it will do is after by handovering its own subscriber to another base station, it will take care of the person who is coming near to the base station 2. So this can be one case, or it can be case like when there even though the adjacent base stations are congested and they can't serve, then what it will do, even though it is closely prompting to base station 2, until and unless it loses complete connection with base station 1, it will be connected to base station 1 because base station 2 is not free to serve the mobile. So these are these are three scenarios, and call drop rates, based on call drop rates also, like based on congestion only call drops will happen. So these are the scenarios, like these are the factors, and there may be many other factors which will be influencing this handover, whether to hand off or not to hand off. Yeah, and say that like that is said, like handover in the sense everyone will be saying like this, like while moving from this to that is handover. When coming to new concept, like when mobile station switches from one video resources to another set of resources, handover is said to be takes place. In the sense, see, you communicated with the, like in the previous image, you communicated with the mobile with the base station 1 and you are moving to base station 2. So what happens? See, when you tell like you are communicated with base station 1, all the resources, and you will be allocated with certain resources in the sense just be blind, like resources in the sense in terms of frequency and time, like these two things only you will be allocated with. And by using these two things only, you will be transmitting your data, right, at a particular point of time with some frequency something. So that is nothing but some resources are allocated to you. So these are resources in the sense in terms of frequency and time. And so whenever you are moving, so whenever you are telling like you are connected with base station 1, that resources are allocated to you. Means like base station will be telling like at this time you are transmitted, these are the frequencies allocated to you, because base station is the one which will which will allocate the resources, because base station has many mobiles under this, right? It will maybe 100 mobiles. In GSM it is serving 11 10 mobiles, and one is for some other purpose. And so when it is serving 11 mobiles, like it will be asking for resources. Like I want mobile will be initially requesting for to transmit something, and I want to make a call to some other person. Please allot me some resources. It will be requesting base station, and base station in turn will provide. See, these are the time slots provided to you, and this is the bandwidth provided to you. So please use this bandwidth. So then the mobile will be using this bandwidth and using this time slots to send some data this. So some set of resources are allocated from by this base station to this UV. So whenever you hand over, like these set of base station, like these set of slots or these things should be handed over to target set, because UV will be thinking that like sourcing, like you don't be having awareness of what is happening internally. Your mobile will be thinking these are the resources allocated by me, using at this time slot. But whenever you hand over to some other, whenever your phone is handed over from one mobile station to another mobile station, one base station to another base station, then like this, like what are the slots allocated, what are the frequencies allocated, this should be all the user profile maintained in base station of this particular subscriber. This should be transferred to the target base station, right? Then only you will be you will be keep on sending, even though you are moving from one cell to another cell, you will be using the same slots and same thing. So this set of resources, this context should be transferred from base station A to base station B. Then only base station B will be will be capable of handling this mobile station. I think you got the point. Like user context should be moved from the resources allocated should be moved from one set of base station to one base station to another base station. The same thing is here. Like when mobile station switches from one set of resources to another set, handover is said to be taking place. Okay, see the same thing. User is here and he is moving from old base station to new base station. Same thing is here. And handoff decisions. What do you think? Who will take care of this handoffs? Mobile, network, or who is taking these handoffs? So there are numerous methods for performing handoff. From decision point of view, we are having three of them can initiate this handoff. I mean, three of them can make the decisions whether to hand over to a target cell to some other cell, or whether this itself can serve the services. So under that, these are the three things: handoff and mobile control handoff. Let's see what it is. Network control handoff. Network in the sense, what do you mean by network? Network in the sense, the same thing, right? Base stations, right? In network control handoff, the network may be, in network control handoff protocol, the network makes a handoff decision on the measurements of the MS at number of base stations. So what it will be doing, like you will be giving reports, but it makes handoff based on movement reports. Like what it will do is the mobile station will be surrounded with some group of cells. So it will be providing measurement reports, and based on that, network will be deciding whether to hand off or not to hand off. Because you are providing all the results, right? See, this cell is serving me. Suppose you are surrounded with 4 cells or 4 cells. See, cell A is giving me this much of power, this much of quality. He will be giving this. Like these 4 factors, whatever I told, not 4. Congestion can be told only with the base station. Only things can be told is channel quality. What is the quality of the channel? What is the signal strength? Because UV can be, whenever it is surrounded with 4 base stations, it will be receiving from the 4. It will be receiving signals from the 4 base stations, right? So it will monitor that signal strength, and it will be giving the reports to base station network. So that networks will make the decision based on the measurement reports received from the mobile stations. Okay, in general, handoff process takes 100 to 200 milliseconds. This everything is in PQ of GSM. Okay, when coming to know, it is like no time is taking. It is called a seamless handover in 4G. Now it is like whenever you use from one tower to another tower, it is taking 100 to 200 milliseconds in GSM. And network controlled handoff is used in first generation analog systems, since at AMPL like in 1G it is used mainly. And mobile assisted handoff is mobile will be taking the measurements. Yeah, in mobile assisted handoff the same thing, but here mobile is assisting, like my signal strength is going down, this signal strength of the target cells, I mean these are the signal strength of the neighbor cells which are here. I want to, since the signal strength of this target B, maybe if you are having A, B, C, D as base cells, base stations, this the power received from the target base station B is more high, so I want to hand off to this particular base station, so please provide me the access. Like this it will be asking the network. So since the mobile is assisting the network to hand over to particular cell, it is selecting the target cell and it is asking to hand over to that particular cell. It's called as mobile assisted handoff. In a mobile same thing, assisted handoff, the mobile network makes the decision. It will make the measurements and it will give to the network. Here directly network is taking the decision, no mobile and nothing. But here based on the things, based on the measurements, it will be taking. Here base station will be monitoring the mobile stations and based on that it will be taking. But when it is mobile assisted, it will be providing measurement reports and based on that network will be decided. In the circuit switched GSM, the base controller is in charge of radio interface management. Here in GSM we are having base station controller and transceiver, right? Transceiver is nothing but transmitter and receiver purpose, but the whole controlling operations will be taken by BSC. It is in the charge of radio resource management, like what radio resources to be allocated and where to be allocated. These things will be taken care by BSC. This mainly means allocation and release of radio channels and handoff management. During the handoff, what are the resources that need to be handed over to target cell and what are the things that should be taken care of, that things will be taken care by BSC. The handoff time between handoff decision and execution in a circuit switch is approximately 1 second. Here it is approximately 1 second, whereas in previous I think it is 100 to 200 milliseconds, right? Handoff process. And the execution in circuit switch, this is in circuit switch, it is 1 second. GSM is circuit switched, but GPRS is packet switched. I hope you remember. GSM is 2G, 2.5G, from GPRS, packet switch has started. And mobile controlled hand, the other thing is controlled handoff. In mobile controlled handoff, each mobile station is completely in control of handoff process. Okay, this type of handoff process is short reaction time. MS measures the signal strength from surrounding base stations and interference levels on all channels, and handoff can be initiated if the signal strength is lower than the same thing. Mobile controlled in the sense, like mobile will be telling, say here the difference can be like, here network is doing directly the handover, here mobile is assisting, like I want to, like these are the reports of this, based on this select some better tower and provide me handover. But the third case is itself it is deciding what base station to hand over and which base station to hand over. So this is maybe in terms of 0.1 seconds, because it is less, right? Since the decision is fast and the implementation can also be, yeah, okay, fine. Yeah, you can download the PPT now. So you got the difference between three, right? Here what it will doing based on the measurement reports, it will be suggesting based on the channel quality, based on these things, it will only be like requesting this is the target ID, and with this target ID, please do provide resources for this target ID, like do hand over to this target cell, target ID in the sense target cell. So the three different handoffs. See, handoff can be initiated if the signal strength of the serving cell is lower than another base station by certain threshold. Actually, for every base station, we will be having threshold levels. So once for triggering this handover, we are having different algorithms like event-based algorithms and measurements-based algorithm. Events-based in the sense like we'll be having one threshold value for each base station, and based on this threshold, if base station A, base station B, mobile is moving towards base station B. If the signal strength of base station A falls below this threshold, then only you can hand over to that other cell. So the threshold values will be maintained for each and every base station. Okay.
961.
Types of handover. What are the types of handover? We'll be having hard handover, soft handover, horizontal handover, and vertical handover. Okay. Yeah, let me cover it quickly.
9229.
Hard handover. What is hard handover? Hard handover in the sense whenever you are handing over from one tower to another.
Malaysia దగ్గర ఉన్నారు సార్.
That base station. Initially, whatever you are connected under that state. So when you want to switch to some other base station, then it will be breaking the connection with the first base station first, and then only it will be connecting to some other base station. Since it is in order of some microseconds and milliseconds, you can't be recognizing that call termination in between. Whenever you are moving, you can't you will be keeping on talking, but you can't just realize that time lapse between this. Like when it is handed over, you can't even recognize that. So, but it will happen. The breaking of call will be happening, and again establishing will be happening with other tower, and in the sense target tower. Before making connection to other tower, you are breaking the connection existing tower. So then only you will be capable of making it to in hard handover. Then only you will be establishing connection with the tower 2. So this is called as break. Break it before making the connection with tower 2. So connection is broken before a new connection is activated. Primarily used in FDM and TDMA systems. Example is GSM, as you know. Different different frequency changes used in adjacent cells to minimize interference. See, suppose you are having to maybe like our geographical area is divided into cell. I told you in the initial frequencies in cell A and cell B. If the mobile is going from cell A to cell B, maybe he is in the intermediate, then like there may be some other mobiles using the same frequency in the cell B. So what happens is there are two users, both of them are using same frequencies, and both the cells are adjacent to each other. So whenever he is in intermediate, like whenever he is in the of cell A and cell B, he'll be receiving signals from both. So what happens is that interference will happen. So mobile A and mobile B, both of them are not capable of receiving the like you will be hearing mobile B's voice. If B is speaking to some C and A is speaking to some D, A will be hearing C's voice, and this interlapping will happen. Sometimes also whenever you are making calls and whenever you are on call, you will be hearing some other voice, some other person's voice. You don't know who is, and like this is called as like this can happen, right? Like crosstalk. Like you're calling to some person. These things happen, and in between, like in this purpose, like in hard handover only, these cases can happen. Like some other things will be involved. So different frequencies. Whenever you use same frequencies in adjacent cells, interference happen. Because of that, only will be having such kind of. So generally we'll make sure that whenever they deploy tower and whenever they ask this, is the frequencies used concept comes into the picture. So frequency is used in the sense, say you are having one frequency. If you are to one user, then it is of no use, right? So what they'll be doing is, I mean, network operators, they'll be using like you're having A, B, C, D. So A will be having one frequency, B will be having another frequency. I mean, in the cells you are having many frequencies, but maybe mobile I'm speaking about. So mobile A is using frequency 1 and mobile B is using some frequency 2 in the adjacent cell. So C will be using the same frequency which is present in A. There is some distance between them. Even though they use the frequency, there will be no interference which will happen. So this is the same point. Different frequency ranges used in adjacent cells to minimize the interference. So different frequencies should be used in adjacent cells. If you want to reuse the same frequency, just use it at some other geographical location which is some far from the existing cell. When you see that how the cells are made and what are the constraints for that, then you will be seeing some hexagonal cells, right? That can be divided based on the density and these kind of stuff. That can be sectorized, directional antenna. So based on the percentage of people in particular area, if it is urban, and if it is some rural areas, since people are scattered, I mean, the people will be more and people will be less, right? In such places, they will be using omnidirectional antennas. So one cell only will be covering the entire zone. So these are some of the scenarios. And okay, mechanism of handover. What exactly happens is, see, here we are having before handoff and after handoff. The base station on one cell side hands off the mobile station calls to another base station. This is the link to the prior base station. Base station 1 is terminated. See, suppose maybe he is here and he is moving near to that. So it will be terminated with this and it will be connected to the same thing I explained. No need of explaining this again. Okay, let me go with the next slide. Okay, what are the characteristics of handover? What do you think? Is it effective or not effective? Because you are breaking before making with some other base station, right? So what happens? Related is different. So the base station and this is different. So this is some physical connection which is established between two is break, and then once the connection existing, then the circuit or the hardware involved can be costly. But since you are terminating and initiating it, something like restart. But restart in the sense with same system. But we are not using the same system. We are handing off to other system. So this is cheaper, right? Because hardware itself is looking simpler. So a hard handover is relatively cheaper and easier to implement in comparison. Even for implementation wise also, it is cheaper and comfortable. It is primarily used in FDMA, TDMA, where different frequency ranges are used in adjacent cells to order to minimize the channel interference. The same thing which I told now. It is a simpler as phones hardware does not need to capable of receiving two or more channels in the, even phones hardware can also be simpler, because if you want to receive two signals at a time, you'll be having antenna types like MIMO, CISO. CISO in the sense single input, single output. You can send the signal through one output, I mean through one channel, one output channel. If you want to send something, you'll be having channels. So in that MIMO in the sense multiple input, multiple output. You can transmit via multiple antennas. These are antenna configurations, whatever CISO, MIMO, single input, multiple, CMO, MISO, like will be using UV in 4G. The mobile station is called as UV in 4G actually. So because of that, I am getting this term regularly. So this mobile, like based on the services, if you want to transmit 3 to 4 at a time or receive at a time, then you will be going for MIMO configuration. So now since we are receiving only one signal from only base station 1 you are terminating, then only you will be connected to that. In the sense you will be receiving many signals, but out of that you will be connected with only one thing, one hardware device. So there is no, like there is no nothing in parallel, right? So this is the same way. Because of this, the hardware is also no need of changing some changes to hardware. You can implement with the help of CISO. CISO in the sense single input, single output. No need of multiple inputs and multiple outputs, right? So because of this, the hardware is also cheaper. Yeah, what is intercell and intracell? This thing I explained. Intercell in the sense inter and intra. Intra in the sense within the cell. Intra in the sense with out of cell. So inter in the sense both mobiles are present in the same cell, then it is called as intracell. And intercell in the sense the mobile is under some other MSC and some other BSC, then it is called as intercell. Same thing. The intercell handover switches a call in progress from one cell to another cell, and intracell handovers switch a call in progress from one physical channel of a cell to another physical channel of the same cell. Intra same cell, inter out of cell. Just keep in mind of that. Inter, intra, everywhere it will be the same. The meaning will be the same. So soft handover. What is soft handover? Make before break. In hard handover, you are breaking and establishing the connection to the target cell, target base station. Here it is not the same. So before you are establishing the connection with the second, before you are terminating with the first cell, you will be establishing the connection with the second cell. So here hardware comes into the picture, and like multiple, you will be receiving two signals at a time. So multiple outputs, multiple inputs you will be taking. So my ISO will come into the picture. So the configurations will be changed and the hardware part will be changed. UV side it will be changed, right? So and the implementation wise, design wise also, it will be more costlier when compared to hardware. New connection is similar. New connection is activated before the old is broken. So yeah, new connection is activated before the old is broken, and used in UMTS to improve the signal quality. So what happens is, you can't now when you are speaking phone, you can't even, there is no lapse of even millisecond and microsecond of time, right? There in hard handover there may be some lapse, but which you won't recognize. Because of that only we are not like, sometimes when you are moving fastly, sometimes it may get like beep, like no sound in between. It may last for some nanoseconds and microseconds of time, which you can't realize, but sometimes you can notice that. That will be some hard handover, but this will be seamless handover. Before establishing itself, before terminating itself, you are establishing. So it is a soft handover. Same thing. Uplink and downlink may be combined for better signal and better connection reliability. Seamless handover. Seamless in the sense no termination, nothing. Like whatever you same consistency. That is called as seamless. Okay. And hardware will also be costlier when compared to that. Mechanism of soft handover is something. User is moving from one to other nodes, and then also he'll be connected to both. Once he is connected with node B, then only he'll be terminating his connection with node A. Same thing, the call is connected to the new base station and then dropped by the previous base station. The call will be established only when a reliable connection to the target cell is updated. The mobile station is linked to two base stations for a brief interval of time. Handover involves connection to more than one cell, right? Two cells you are connecting as of now. Thus, it involves connection to more than one cell. And coming to the characteristics, yeah. It offers more reliable access, continuity in your mobile call or whatever data access you are doing. If there will be some continuity, and less chances of call termination during switching of base stations in compared with hard handoff. In hard handoff, you are breaking, and there may not be resources available, or you may not establish connection with target base station. Then your call will be terminated, but there is no chance of terminating here because you will be establishing connection before itself. Then it will be, if it is unable to allocate resources or if it is unable to serve you, it will be intimating you. Then only you will be, if it dislike it or don't have any, if it don't serves this particular user, then you will be continuing with the previous base station only. So If it has resources, then only you will be doing handoff. So there is no call termination process which will be happening here. The chances will be less. It is commonly used in CDMA, code division multiple access systems, like CDMA, WCDMA, wideband CDMA, narrowband CDMA. These things will be used in 3G actually. Enables the overlapping of repeater coverage areas. Repeaters are nothing but to enhance your signal. You are transmitting something. It may fade, like it may because of the nature calamities, like maybe because of different waves present in the nature and different dust particles, rays. Because of these things, your wave may get like distorted and it may lose its signal. The signal may become weak. So we'll be using repeaters at every instant of time so that repeat the same thing. Like it will be like amplifying the thing and it will be sending out. Like if you, it will be like repeating the same signal so that we at destination will be reaching the signal will be reached. Okay. Yeah. So that a cell phone set is always well within the range of at least one of the people. Okay. Technical implementation of a soft handoff is more expensive than hard handoff. It is used in sensitive communication services such as video conferencing. Right? Yeah. Softer handover. Softer handover is the situation where one base station receives two signals from two adjacent sectors it serves. Same thing I explained. Due to reflections on buildings and natural barriers, the signal sent from base stations reaches the base station from two different sectors. This is one image related to that. Horizontal handover. What is horizontal handover? Horizontal handover in the sense when mobile terminal changes its point of connection within same type of network. Yesterday I told like we'll be having 1G, 2G, 3G and LTE. LTE is nothing but 4G. So, yeah, just a second. Hello. Get like the tower is not capable of serving you with, you subscribe to 3G services or 2G, maybe you are subscribed to 3G services, but like where the place where you go it can't afford or the tower can't support the 3G services. So your phone will be switching back from your network will be switching back from 3G to 2G. That is the reason sometimes you'll E for E symbol, H symbol, it will be falling back from one network to other network. This is the same case. So horizontal handover is when mobile terminal changes its point of connection within the same network. And whenever like from a cell to another cell in GSM. See, one you are handed over from one cell which is using GSM. The other cell is also GSM. Then it is called as horizontal handover. But whenever you are having some other network, cell A, tower A, base station A is using 2G GSM and base station B is using some 3G. Then if you hand over from base station A to base B, then it is called as vertical handover. Here it is called as within network in the sense same GSM, LTE, 3G, UMTS, 1G. 1G you don't have this kind of thing anyway. So 1G you can't hand off to the below network, right? So this, whenever it is same kind of network, it is called handover. Reasons for handover can be, examples can be from a cell to another cell, from one access point to another in the Wi-Fi. Reasons for handover: worse signal quality or loss of signal, load balancing, cost. Cost is one of the thing, and traffic load balancing in the sense congestion kind of thing. No, it is congestion. And worse signal quality in the there is no signal, then only you'll be signal strength is less, then only you'll be handed over, right? Same thing. See, same thing, same network, both are of same network, but different cells, maybe adjacent cell. So it is getting handed off from one to other cell. Then it is called as horizontal handoff. Suppose instead of WLAN you are having GSM, and instead of in this tower B you are having say UMTS. Then it is called as vertical handoff. I think it's clear. Vertical handoff same refers to a network node changing the type of connectors to access a supporting infrastructure, usually to support node mobility. The only thing is to support the mobility. And vertical handoff refers to automatic follower from one technology to another in order to maintain communication, in order to continue your call, in order to continue your data services, in order to continue your multimedia services. These, for continuing this, you will be hand over from one network to another because you don't have there that network which you subscribe to. So this is vertical handoff from GPRS to WLAN. And one example. Okay. Capabilities of vertical handover has come with horizontal handover. So what are the capabilities? Since it is capable of accessing different networks, horizontal handover can't access different networks. Only within same network only it is handing off, right? So vertical handover can have these many capabilities when compared to horizontal handover. Usage of different access technologies. It can use different access technologies. Suppose you are falling from 3G to 2G. In 3G you will be using CDMA, and in 2G you will be using FDMA. And also in 3G you will be using like WCDMA, these things you are, and here you will be using GSM. And multiple IP addresses you can use, right? And multiple interfaces will come into the picture, and usage of multiple QoS parameters, because quality of service falls, right? Whenever it is 3G, you will be provided with good services. Whenever it is 2G, you will be provided some normal services. So quality of service parameters also changes. So vertical handover has capability of using different things like different techniques, different parameters, different addresses. These are the some of the capabilities for vertical handover over horizontal handover. Usage of multiple network connections. Multiple network connections. Yeah, handoff failures. What happens whenever some handoff is failure? Because when that situation comes, because frequencies cannot be reused in adjacent cells, when a user moves from one cell to another, a new frequency must be allocated for the cell, as I told you. Interference comes into the picture, so because of that he can't hand over, and call termination may also take place. If a user moves into a cell, when all available channels are in the use, the user's call must be terminated. It will be adjacent case. There are no available channels, it can't serve, so call will be terminated. And the other thing will be interference. Yeah, this is done. Let me have some discussion of protocols. If I cover these protocols and then I'll be left with GPRS topic. Once that is moved to MAC layer, like media access control. Okay. Yeah, I just took this PPTs for reference purpose. I took from Google only. So that is the reason I didn't change anything. I just want to use this as a reference. So what is GSM? What are the architecture? What is the protocol stack? And how the call process will be. Overview of layers. What layers it contains. GSM, you know, and these things. And what are the network elements? You know, what is a NSS, what is MSC, these things. And GSM protocol stack. I told you, like in protocol stack, whenever we say some protocol stack, I told you to compare with OSA, right? Here you will be having only 3 layers, but in OSA you will be having 7 layers. But like here, what it will be having is even these 3 layers will be taking care of the remaining layers. Suppose layer 3 networking layer will take care of, like layer 2 will be take care of things, and layer 3 networking layer will like some messages in like some significance of session layer and application layer. So in GSM you are having only 3 layers. One is physical layer, 2 is data link layer, and will be networking layer or messaging layer. So in telecommunication system, signaling is required to coordinate the necessary distributed functionality entities of the network. The transfer of signaling information is as follows. So whenever you want to establish something, some information should be exchanged, nothing but signal. Nothing but control information should be exchanged. If you want to talk, you can't directly switch on your mobile and talk. There will be some hundreds of processes going in order to, before you make a call, like it will be up, phone will be up, and after that it will be searching for the signals, and then it will be receiving the signals. After receiving the signals, it will be receiving signals from many base stations, and it will filter one base station out of that. Then it will be registering to that particular base station, and this mobile will be registered with MSC. And after this registration process, then there will be some authentication procedure happening, and integrity protection happening for the messages, control messages. And after this, it will request for resources, and base station will be providing you the resources. After resources and everything is done, your connection is established, like then only you will be getting your call. So these are the control messages. Like signaling should be required in order to coordinate some functionality, right? Yeah. So physical layer, in the sense I told you, radio link. What do you mean by radio link? If radio link fails, what happens? Yeah, we'll discuss anyway. So this is physical layer, in the sense radio transmissions. Whatever is in air, just blindly think it of as physical layer. Whatever is transmitted out without doing any changes, nothing. Only respective to the transmission of the signal. In order to transmit signal into air, you'll be using modulation techniques, multiplexing. Only these things, whatever changes you are doing in order to use physical layer. And for packets, like till physical layer, it will be in terms of packets from application layer, session layer. Like here, it will be networking layer. From networking layer, you'll be getting packets. In physical layer, this will be converted to analog signals with using digital to analog modulation schemes. So till that point of time, there will be some enhancements done at each level, adding of headers, adding of some bits. If you take data link layer, like it will be main functionality of it will be flow control and error control. In the sense, error detecting, it will detect the errors, and it will also correct the errors by doing retransmits. I told transparent mode, non-transparent mode. You remember, right? In transparent mode, only physical layer is involved, but in non-transparent mode, you'll be having data link layer together with physical layer. So it will do retransmissions. Transparent mode will be having redundant bits, and forward error correction will be used by transparent. But in trans mode, you will be having retransmission. So whenever some erroneous data is received, the receiver will send, like suppose you are sending some 10 sequences, like 10 packets. Each packet will be assigned with sequence number, right? Sequence number 0, you are sending it to receiver. Sequence number 0 received. Sequence number 1 you are sending, but 1 is not received. And sequence number 2 you send, sequence number 2 you received in the receiver side. So what it will be doing is, it will be giving acknowledgement to the last sequence number we received. So what will be the acknowledgement sequence number now? It can be 3. Since you received 3, the next it will be giving ACK sequence number as the next sequence number, which is yet to be received. So ACK sequence number will be now 4, but the NAC sequence number will be 1, right? Since you received 0 and 2, but you didn't receive so NAC sequence number will be 1, and acknowledgement sequence number will be 4, because 4 is yet to receive. Once if you receive 4, it will be ACK sequence number will be updated to 5. By this time, if you don't, that transmitter if supposing it didn't retransmit NAC sequence number 1, it sent negative acknowledgement, but it didn't retransmit. Then also it will be providing NAC sequence number as 1 until and unless it gets transmitted. Whatever is not received or whatever is corrupted, and when it requests, it has to retransmit that particular packet. So this is how happens. Flow control and error control will be happening in the layer 2, and this is interfaces used in layer 2. We'll discuss that in detail. And this is the networking layer. And networking layer, you know, the allocation of IP address, mobility, allocation of resources. These things will happen in the networking layer. Okay, this is GSM protocol architecture, and here this is mobile station. This elements, you know, what are the elements which are some architecture, you know, but in each element, mobile station, you are telling mobile station and it contains hardware, but what exactly it contains, what protocol stack contains, and what are the different layers involved in that, and what is the functionality of each layer. Let us discuss that. So in mobile station, you will be having this radio in the sense layer 1. See, basically you will be having mobile station, base transceiver, and base station controller and MSC, right? So here, see, I told this is radio link layer. This is layer 1, and here only radio will come into the picture. Radio link in the sense air interface. So radio will come into the picture, and here you will be using TDM and FDMA, whatever multiple access techniques modulations. This only you will be using in radio link layer of base station and mobile station. And layer 2 is nothing but LAPD. Nothing but link access protocol D channel. This is nothing but layer 2. In your GSM it is layer 2. So in order to access the link, so that is named after this link access protocol D channel. And after this you will be in MS stack, you will be having RRM. RRM is nothing but radio resource management. How you are managing this, what you know, like what base station resources are allocated to you and what you are using, what are the different time slots. These things will come under radio resource management. And this is mobility management, and this is connection management. Connection management in the sense like how connection is established, how much time you need to how much time that session should be maintained and when that session should be tiered off. Those kind of things will come under connection management. And when coming to mobility management in the sense when you move to some other place, what are the services provided to him, what are the supplementary services, these things will come under management. Whenever you move, services offered to you is called as mobility management. So these are the things present in mobile stack, and this is base station, right? In base station you will be having radio link, same physical layer, and LAPDM. And see the interface between mobile station and base station, it is LAPDM, and between base station transceiver and base station controller, it is LAPD. Okay, just make a note of that. And see, one part of it is connected to mobile station, base station transceiver, and the other part will be connected to base station controller. In base station controller, you won't be having like a radio link, these kind of things. Why? Can you answer me? You don't have radio link between base station and base station transceiver and base station controller. What do you think is the possible thing why we don't have that radio link between them, established between them? So if there is no radio link, how the connection is established between those two? I think you know, and even I explained in some session. Why there is no radio link, radio link layer, physical layer in base station controller? Please do respond so that I will continue for another 15 minutes and we have more things to discuss also. At least if you don't know something, just reply me that no, we are not aware of that. That kind of replies, I think it will be good because I can proceed at least. If you know, you can just answer me. So you are listening, or what can I take? Like you are listening, everything is going in, or you are not at all listening? Or you know this concept earlier itself? What can I think? Why there is no radio link or radio layer in BSC? Are you getting what I am telling at least? You can are you able to correlate with the real-time things when I am explaining? If not, you can just tell me what enhancement should be done. Okay, let me continue. So whenever I am talking about base station controller, here mobile station and base station transceiver are connected with the help of radio interface, but not the base station controller, right? Base station transceiver and base station controller are connected. Yeah. Base station transceiver and base station controller are connected with the help of wired medium. So that is the reason there is no need of having radio interface in between base station transceiver and base station controller. Okay. Yeah. So in base station transceiver we are having a connection established between base station controller and base station transceiver with the help of L. And after that, in base station controller we'll be having LAPD for connection with BTS, and we'll be having MTP, nothing but message transfer part, and SCCP, signal connection control part for establishing connection with the MSC. Since it is intermediate, like a base station or intermediate, base station is intermediate to mobile station and BSC, it should support both of them. So whatever layers are present in UV should be present in base station, and also whatever are present whenever it is communicating there should be some common layers, right? So whenever is connected to phases like LAB and this, and whenever this base station controller is connected to MSC there will be some common interfaces like SCCP, MTP kind of things. And in MSC mobile switching center again you will be having the this connection managed mobility management connection only. Here you can observe one thing, the base station only deals with radio resource management kind of things, but mobile switching center deals with mobility, mobile user, and the connection, when like how his connection is still, is he still active or he is not active, whether he is terminated or mobile and mobility, like he moved from one location to other location, so update his location. Like MSC will be the one who will be tracking the user location. Like it will not be done by base station. So that is the thing. That is the reason in base station transceiver we are not having uh, control, connection management and mobility management. We are having only in this like MSC and mobile station. Okay. Yeah, this is some brief architecture of GSM. Yeah, coming to the interfaces, like the interfaces between mobile station and base station is radio interface, and each physical channel supports number of logical channels. We'll be having physical channels and logical channels. I told you we'll be having control channels and traffic channels, and under control also you'll be having common control channels and dedicated control channels, and similar way control traffic and common traffic and dedicated traffic will be there. Okay. And ABs will be the interface between BTS and BSC. Primary functions of this will be traffic channel transmission, terrestrial channel management, and radio channel management. Deals with radio resources mainly. And A is the interface between BSC and MSC. Primary functions are message transmission between BSC and MSC. Okay. Okay, see here, when coming to the data link layer, the data link layer where the radio link is based on a modified LAPD, link access protocol for D channel, referred to as LAPDM. I told you, like interface between these two is LAPDM, whereas the interface between BSC and PTS is LAPD. The layer, same thing. What are the like protocols he is explaining, what are the interfaces present between the layers, he is just giving the summary of that. And user data and control at A interface. So you'll be having data channels and control channels. So data in the sense, control channels in the sense for some signaling purpose, B channel in the sense bearer channel, and D in the sense delta channel. Only thing what are the services it supports and what are the techniques it is using. B channel supports 64 kbps channel. Like in B channel it is having, like we are having 64 kbps channel used for voice, video, data or multimedia calls, whereas in D channel a 16 kbps or 4 kbps channel used for used primarily for patients like signaling purpose, between switching equipment, signaling purpose in the equipment, in switching equipments.
Yes.
Okay, user data and control channel, like user data in the sense, right, traffic or user data, and DM channel for signaling. For signaling purpose we are using this, and for traffic purpose you are using this. Okay. So let us go into physical layer, radio transmission layer. So what are the features supported by physical layer? As I told you, modulation techniques. You know modulation techniques, right? Amplitude modulation, Gaussian modulation, phase modulation, frequency modulation, different modulation, QAMs, we are having QPS case, BPS case, phase modulation. Digital, basically modulation will be divided into analog and digital, and under that we'll be having that. I think we had a session on that, like basic modulation techniques I discussed, right? So those modulation techniques will be work on which to give and what to use in this particular scenario when he subscribe to used in the physical layer. Okay. And the other thing will be channel coding. Channel coding in the sense why channel coding is required. So whenever you transmit a signal, it may be like enforced by some other signals, and it may get faded, it may get multiple parts, and it may get corrupted, and many things may happen, many dust particles, fog, everything is present in environment, right? So because of that, our signal may be lost. So because of that, for that purpose, in order to retrieve our signal in the receiver side, we'll be using channel coding. It is of two types, block and convolutional. In block, we'll be having the data bus. Like each whatever packets are transmitted group, the bits, number of bits will be grouped together, and will be forming blocks, and these blocks will be sent. And suppose if you take some CD, in that you will be, whenever you are sending, it is not like distributed at one place, it will be circularly distributed, because if sometimes some dust may go, like if you touch or something happens, it will be, the CD will be struck at that particular point. So what they'll be doing is they'll be having and then again they may be adding different blocks over there, nothing but block. And for coming to convolutional, you'll be having encoder and decoder. You'll be convoluting with some, and the message code is convoluted with some other code, and you'll be encoding that, and the receiver side also you'll be decoding. Whenever you have the particular code which is used, transmitter side is present, then only you will be capable of decoding that. So the only block codes are more efficient when compared with convolutional, because if you increase the length of the code when encoding the signal using convolutional, then the decoding side it will be a problem, that many bits you need to recover, and the data rate may also decrease, right? Okay, interleaving in the sense, same thing, distribute burst thing, like you are interleaving some slots, like if you take TDM, time division multiplexing, you will be sending in like user 1 is allocated with slot 1, user 2 is allocated with slot 2. Maybe sometimes user 1 is allocated with 2 slots because he is provided with some higher priority. Even users will be given some priorities. So maybe he is allocated with 2 channels. So continuously he'll transmit in 2 channels, but at the third channel, again there should be some interleaving, some gap should be maintained. Otherwise, channel 3 is used by user 2, then this user 1 and user 2's data may collide at some particular millisecond of time. So that is the purpose. In frequency, we will be saying guard band. Here it will be like interleaving, like we are leaving some slots in order to avoid the interference. And power control methodology, like how the power should be. Like maybe base station 2 has some base station 2 has some other same frequency. So if we transmit with low power, and if our thing transmit with high power, so what are the power changes that need to be maintained? These things should be taken care by physical layer. And time synchronization approaches, when to send, what to send, and if we send it this particular time, will the receiver be capable of receiving that, and is the receiver ready or not ready? These kind of things will be taken care by physical layer. Oh, I think it's 10:30, right? Okay, let me explain only this slide. I think, see, this is mobile station. For speech, this is architecture, and base station and controller, and this. And here for GSM voice, what it will be doing in this, you will be having these techniques: forward error correction, ciphering of data, TDMA and FDMA. In order to cipher this, you will be getting keys from MSC itself. Like MSC will be checking from HSC, it will be giving. Here you will be ciphering. Forward error correction in the sense adding of redundant bits. When you send something, you are adding some redundant bits. And multiple access techniques. These things will be taken care by your physical layer. And coming to BTS, same thing. Forward error correction, ciphering and multiple access techniques. Okay. Okay, then these are the things, whatever I told now, channel encoding, these things maybe I'll continue in the next session. Is everything clear till now? So after this, here you are having all the layers, like what network layer deals with, what are the things it is present. So with this will be, I mean, maybe in the next session we'll be completing the complete architecture, and I'll start off with GPRS. So if I covered it, you will be coming to know what is GSM, GPRS architecture second. They will be dealing with like techniques of like multiple access techniques. So this is fine, right? If you have any doubts, you can just ask me in another couple of minutes, and I can wind up today. As I told you, try to solve the puzzles in the end of your, some questions are provided at the end of your textbook. I'm taking reference as Raj Kamal's textbook for mobile computing. If you have that in your library, please to get that book and try to see. And if you want some more topics, and you can just let me know what topics you need, so that I'll be explaining. If you have any doubts, you can come back to me. Okay? Yeah, is this fine? Please do respond. So can I wind up for today? Or you are having any doubt kind of things? Okay, fine. So if you are having anything, share with your coordinates so that I can discuss those topics. Just see the topics. See, I told, right? HS high speed in the sense you'll be having. Can you please enable? I enabled it, right? You can download the PPT. Okay, 1 second. Yeah, you can download the PPT now. And when compared that one, maybe some Vijayanagaram campus has asked me like, why it is multiple access. Maybe in GSM you are using FDMA, then you may be using CDMA and TDMA combined with FDMA. These are the changes. Because of these changes, your data rate will be increased. So this is one of the advantages. When going to some other technology, the main purpose is to increase the data rate. One is increasing the data rate, providing seamless handover, and like good data rates and continuation of services and quality of services. These are the factors which will take into the picture when going from one technology to one generation to another generation. So when compared with HSC, SD and GSM, this is the thing, more advantage. Data rate will be high in that when compared to GSM. You got my point, right? Yeah, both PPTs can. PPTs you can download. I enable, I guess. Yeah, I enabled PPT also. You can download it. Okay. Yeah, fine. Yeah, thank you. Have a nice day. Yeah.
పీపీటీ ఆల్రెడీ మెయిల్కి వచ్చేస్తుంది సార్ దగ్గర ఉంటుంది.
Yeah, thank you. I'm leaving for that.
Respond to your attendance. Roll number 1, present madam. 2, present madam. 3, present madam. 4, present madam. 5, present madam. 6, present madam. 7, 8, 9, 10, present madam. 11, present madam. 12, number 11.